In this video, we're going to practice generating terms of a sequence given nth term formulas like this. So let's take a look at the example. The nth term of a sequence is 4n plus 1, and we need to list the first 5 terms. Now remember, to find any given term, we need to know what position it's in, and that's what n is representing here. So if we want to find the first term in the sequence, what we're looking for is the term when n is 1. When n is 1, we have 4 times 1, which is 4, plus 1, and that's 5. So the first term of this sequence is 5. To find the second term of this sequence, what we're looking for is the value of this when n is 2. That would be the second term. 4 times 2 is 8, plus 1, that gives us 9. So the second term of this sequence is 9. The third term of the sequence is what we get when n is 3. So the third term, that's when n is 3, is 4 times 3, which is 12, plus 1, and that's 13. Pause the video and find the next 2 terms. You should have found the fourth term was 4 times 4, plus 1, which is 16 plus 1, that's 17. And the fifth term is 4 times 5 plus 1, so that's 20 plus 1, which is 21. So those are the first 5 terms of this sequence. Notice that this sequence is going up in steps of 4, so just like we saw in the previous video, this coefficient of n determines the common difference for the sequence. Here's the second example. Pause the video and have a go at this one for yourself. Here you should have got the first term by doing 6 times 1 plus 7. 6 times 1 is 6, plus 7 gets you 13. The second term would be 6 times 2, which is 12, plus 7, which is 19. And carrying on, you should then have got 25, 31, and 37. Notice that this sequence is going up in steps of 6. Okay, with this one, don't get fooled by the order in which this is written. We still do the same thing. To find the first term, we just need to substitute n equals 1 into this. So 15 plus 5 times 1. 5 times 1 is 5. 15 plus 5 is 20. So the first term is 20. The second term would be 15 plus 5 times 2. 5 times 2 there is 10. So 15 plus 10 gives us 25. Carrying on, you should have got 30, 35, and 40. Notice that this sequence is going up in steps of 5, which is the coefficient of n right there. Here's the fourth example. Take care with this one. The nth term of this sequence is negative 8n plus 1. Pause the video and have a go. Well, here the first term would be negative 8 times 1 plus 1. Negative 8 times 1 is negative 8 plus 1. That gives us negative 7. So that's what you should have got first. The second term would be what you get when you substitute n equals 2. Negative 8 times 2 is negative 16. If we add 1 to that, we get negative 15. The third term would be what we get when we substitute n equals 3. Negative 8 times 3 is negative 24. If we add 1 to that, we get negative 23. Substituting n equals 4 into here, we get negative 31. And substituting n equals 5 into this, we get negative 39. So these are the first 5 terms of the sequence. Notice this is going up in steps of negative 8, or in other words, it's going down in steps of 8, but that fits in with what we've seen so far with the other sequences. Here's the fifth example. Now we can generate some more exotic sequences if we like. Take this one. We've got the nth term being n squared minus 3. So the first term would be 1 squared minus 3. The second term would be 2 squared minus 3. The third term would be 3 squared minus 3. The fourth term would be 4 squared minus 3, and so on. So let's work out the first 5 terms. Well, the first term, that's when n is 1. 1 squared is 1. Minus 3 from that, and we get negative 2. The second term would be what we get when we do 2 squared and then subtract 3. Well, 2 squared is 4. 4 minus 3 is 1. The third term of this sequence is what we get when we do 3 squared and then subtract 3. 3 squared is 9. 9 minus 3 is 6. The fourth term is what we get when we do 4 squared and then subtract 3. Now 4 squared is 16. 16 minus 3 is 13. So that's the fourth term. The fifth term is what we get when we do 5 squared and then subtract 3. 5 squared is 25. 25 minus 3 is 22. Now, this sequence is a little bit different from all the ones we've seen so far in the video. All the previous sequences went up by the same amount each time, or went down by the same amount each time. But if you look at this one, it's going up by 3 here, then we add 5, then we add 7, and then we add 9. So we keep on adding a different amount to go from one term to the next in this sequence. It's not like all the previous ones, and therefore it doesn't match a coefficient of n like we had before. This is a different type of sequence, and we'll look into these in a later video. Here's another sequence that's a little bit different from the ones we saw earlier in the video. Let's try generating the first few terms. So the first term is the one where n is 1. 2 to the power of 1 is just 2. The second term of this sequence is what we get when n is 2. So 2 to the power of 2 is 4. The third term is when n is 3. So 2 to the power of 3, that's 2 times 2 times 2, and that gives us 8. The fourth term is what we get when we substitute n equals 4. So 2 to the power of 4, that's 16. And the fifth term of this sequence is what we get when we substitute n equals 5 into here. 2 to the power of 5, that's 2 times 2 times 2 times 2 times 2. And if you work that out, that's 32. Now, this sequence isn't going up by the same amount each time. Here we're adding 2, but then we're adding 4, then we're adding 8. So it's not like those sequences we had earlier in the video, but something is going on here that's quite obvious, hopefully. It's doubling each time. We multiply by 2, multiply by 2, multiply by 2, multiply by 2. And this is also a type of sequence that we will meet in future in a different video. You should still, however, be comfortable generating sequences like this given an nth term formula like this. The only real skill we're using is substituting in values for n, and in this case, because we're always looking for the first 5 terms, we're just going to substitute in 1, 2, 3, 4 and 5 in that order to get our first 5 terms of the sequence. Here's the final example. Pause the video and have a go at this one. Right, so the first term would be what we get when we substitute n equals 1. 1 plus 8 is 9, so the first term of this sequence is 9. The second term would be 2 plus 8, and that's 10. The third term would be 3 plus 8, which is 11. The fourth term would be 4 plus 8, which is 12. And the fifth one would be 5 plus 8, which is 13. So those are the first 5 terms. And you'll notice this sequence is like the earliest examples in this video. It's going up by the same amount each time. In this case, it's going up in steps of 1. Now, what we should spot here is that that does match what we saw earlier on. It's just that there is an invisible 1 here. N is the same as 1n. One lot of n is just n. So this sequence that goes up in steps of 1, notice that the 1 matches the coefficient of n here.